In this problem, we're given f prime of x is equal to x squared times x minus 6 times x plus 6. And we're asked to find where all min and maxes occur, find where f of x is increasing and decreasing, and then give a possible graph for f of x. Okay, so the first thing of note is that this is the derivative function. This is not the original function. This is not f of x. This is f prime of x. And keep in mind that the derivative function, you're dealing with a slope function. Okay, so this represents the slopes of the original function. Okay, so since we already have the derivative function and we're asked to find where the minimums, maximums occur and increasing, decreasing, then we need to find the critical numbers, which means we set f prime of x equal to 0. Okay, so if we set x squared equal to 0, that gives us a solution of 0. If we set x minus 6 equal to 0, that gives us x equals 6. And then x plus 6 equals 0 gives us x equals negative 6. Okay, those are our three critical numbers. So what we're going to do is put those on a number line. Okay, so we've got 0 here in the middle. Here's negative 6 and positive 6. Okay, and we're going to try different numbers in here. So we're going to try a number over in this region. It doesn't really matter so long as it's in that region. You could choose negative 7 or negative 1 million if you wanted. The easiest one to me is negative 7. Okay, and then we're going to try a number in this region here. Let me turn on my lamp. Getting a shadow there. Okay, we're going to try a number in this region here, which would be x is equal to negative 1 is the easiest number I can think to try there. You can try any number in that region. X equals 1 is a good one over here, and x equals 7. Okay, so remember, we're plugging into the derivative function. Okay, so we're plugging in the derivative function. We're going to try these numbers to see what the derivative is doing, and then we're going to be able to say something about the original function. Okay, so if we plug in negative 7, remember we're plugging into f prime of x is equal to x squared times x minus 6 times x plus 6. Okay, all we care about is positive or negative. I don't care about the actual answer. Okay, we care about whether the actual answer is positive or negative. So if we plug in a negative here into x squared, everything gets positive. So for our purposes, this x squared is not even going to be relevant when we start talking about negative or positive. It's just these two parentheses. Okay, so if we plug in a negative here, that parentheses will end up being negative 13, and this will also be negative, which will be negative 1. So negative times a negative is a positive. So in this region here, the derivative function is positive. So since the derivative function is positive and the derivative function is the slope function, that means the slope of the original function in this area is also positive. If the slope is positive, that means the function is going up as it travels from left to right. Okay, so it's going uphill there. Let's try the next region. Negative 1. Again, x squared is always positive. So this one, plug in a negative 1, it's negative. This one, plug in a negative 1, it's positive. So negative times a positive is a negative. So this will be negative. And since the derivative function is negative, the slope of the original function is negative. So it's going down as you travel from left to right. Okay, moving to the next region, we decided to try x equals 1. Plug in x equals 1. This gives us negative when we plug in, and this gives us positive. So negative times positive is also negative. So this is negative, and this is also going down. The original function is going down. The slope's negative. And then for our last region, we decided to try x equals 7. So I'll plug that in, positive, this becomes positive, this becomes positive. So the whole thing, every term here is positive, which means it's positive, and the slope is positive. Okay, so what did that do for us? Well, we've written down what the function is doing on that area, and we can see that as we are coming from this direction, from negative infinity, until we get to negative 6, the function is increasing. And then it stops increasing and starts decreasing. Okay, and at negative 6, that was our critical number. That's where f prime of x is equal to 0. At negative 6, the slope is 0. So it's going up, hits a 0 slope, goes back down. So this is a local maximum. Okay, and then as we keep going, we go down. We hit a 0 slope here as it levels out, but then we keep going down. So this is maybe more of a saddle point it keeps going down. So that's not a local min or a local max because it levels out, it keeps going down. But then as we get to 6, we keep going down, 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 down until we hit 6, and then the function starts going up again. Okay, so it does this here at 6. So that is a local minimum. Okay, so we're looking for our local min and local max. I'll start with max. So the local max occurs at x is equal to where at? -6. Okay, and local minimum occurs at x equals 6. Okay, now we can't actually figure out what the value of the max and min are there because we don't have the original function. We would need more information to determine what the value of those are, but we do know that they do occur at -6 and at +6. Okay, so next question, it says where is f of x increasing, decreasing? Okay, so we can, again, we don't have to do any more work. It's already all right here. So let's start with increasing. It is increasing since this function is unrestricted, so it goes from -infinity to infinity. So it's increasing all the way till it gets to -6. So I'll say it's increasing from -infinity to -6. -infinity cannot be included, so that's a parentheses. And 6, now our -6, can that be included? Well, we said that at -6, that's where the derivative is equal to 0. The derivative is equal to 0, the slope is 0, and it's not increasing, it's flat. So we're not going to include -6 in increasing. Okay, and then there should be another region. We keep going, we're going down, down, and then here we start going up again. So at 6, all the way out to infinity, we are increasing. Okay, and again, I'm not going to include 6 because the slope is flat there, slope is 0, and infinity, you never include that. Okay, because that's not a number. Okay, so decreasing. Again, look at the graph here, or look at our number line rather. So it's decreasing from -6. It levels out, but then it keeps going down. So you can write this in two different ways. Both are commonly accepted. You can either just say it's from -6 to 6 and be done with it. That's an acceptable answer for most people. Or you could write that you could write this -6 to 0, and then from 0 to 6. Okay, depending on who you're giving the answer to, either one of these could be assumed to be correct. Okay, and finally, give a possible graph. Why does it say possible instead of just give the graph of x? Well, it's because we don't have enough information to give the exact graph of x. We would need to know a lot more. We'd need some sort of initial condition to say like f of x is equal to this number when x is this, but we don't have any of that. We're just given the derivative here with no further information. So we can sketch a possible graph, but we have no way of knowing what the graph actually looks like. It could be shifted up and down, or it could have a faster or slower slope. There's quite a bit we don't know about this, but we can sketch it. So going out to -6, +6, doesn't have to be exact, it's just an idea. So looking at this, it goes up, levels out, goes down, levels out, down some more, levels out, goes back up. Okay, so it hits its maximum or local maximum at -6, so I'll just put a little dot. Doesn't matter where I put that dot, that's just a reference point. And then I'll also put a little dot at 6 to say that that's a minimum. Okay, so I'm going to say it looks something like this. Maxes out, and then as I get towards 0, it's going to level out, but then it's going to go back down. Okay, so that's a basic idea. So this little, make sure you get this little saddle point in here, in here where it levels out. That's the main thing. So you know that it has a max here and a min here, but make sure you hit that little middle point or you'll get the sketch wrong. And this thing could be anything that looks relatively like this could be the graph.